Solving logarithmic equations. A log equation is just like any other equation. You are solving for x or any other variable. The easiest log equation to solve is the simple log base b of x equals y, where you only have one unknown. The first example is exactly this. Log base 5 of x equals 2. The easiest way to solve this is to rewrite it in exponential form and then solve. Now I will show you how to solve when there is more than one x. Log base 2 of x plus log base 2 of x minus 3 equals 2. The main goal for this kind of equation is to get all of the x's together. To do this, you must use the product law to rewrite it as log base 2 of x times x minus 3. Once you rewrite the equation in exponential form, you will see that you end up with a quadratic. 0 equals x squared minus 3x minus 4. After this is factored, you get the answers x equals 4 and x equals negative 1. At the end of every equation like this that you solve, you must check your answers by plugging them back into the original equation. The original equation was log base 2 of x plus log base 2 of x minus 3 equals 2. It is only possible to take the log of a positive number. When you plug in 4 for x, both logs are of positive numbers, 4 and 1. Therefore, 4 is an answer. Now you have to plug in the other answer, which was negative 1. When you plug it in for the first x, it is already negative, so you know that negative 1 cannot be a real answer. Now I will show you how to solve something called a logarithmic quadratic equation. Log x times log x plus 6 equals the log of x to the 5. Log x times log x is the same as saying log x squared. Once you pull the 5 down from being an exponent, you can clearly see this equation start to look like a quadratic. The tricky part here is that you have a log x instead of a single variable x. In order to make the equation seem more simple, you can sub in another variable for the log x's, then sub them back out later when you have your answer. I chose the variable a. After replacing log x with a, we now have a squared minus 5a plus 6. Now that we have a simple quadratic equation, you must factor to find that a equals 2 and a equals 3. But this is not your final answer. You must always remember that you subbed in a for log x. Now you must plug log x back in for a. When we wrote a equals 2, we actually meant that log x equals 2. Now you can rewrite log x equals 2 into exponential form, remembering that a log without a base has the base 10. X equals 100 when solved. A also equaled 3, so log x equals 3. Rewritten, you will find that x equals 1,000. Therefore, x equals 1,000 and x equals 100. The final type of equation I am going to show you is an application of a logarithmic function. You may have seen this formula before. It is called the population growth and decay formula. P equals P naught times r to the power of t over n. If you don't know what each variable in the formula means, just pause the video and read the small descriptions in red. Using this formula is very simple. Just plug in everything you know from the word problem, then solve for the unknown. Here is an example. 10 grams of bacteria doubles in 10 minutes. How many bacteria will there be after 1 hour? Now you need to identify which values go with which variable. Use the prior descriptions in red if you need help. Once you do this, you can simply plug in the values and solve for the unknown. Pause the video if you need further clarification on how to solve. But how does population growth and decay relate to logs? Well, if the question asked how long it took for something to grow or decay, that is, if there was an unknown in the exponent, you would need to use logs to bring the variable down, as seen with 6 equals 7 to the x. Here is a growth example. How long does it take for the previous population of bacteria to grow to 200 grams? Using the method from the simple example shown before, you can easily solve for t by using logs. If you need further clarification, just pause the video to view each step in finding t. I hope this video made solving log equations easier for you. Thanks for watching!